It is day 23 in Algebra 1, and it is Wednesday, April 30th. Tomorrow is May. That's crazy. Time's just flying. I know it. Half the year's gone. Wednesday, April 30th. Okay, so for your do now, I gave you 3 sets of binomials to multiply. And I gave you some tricky ones for numbers 2 and 3, since we've done so much practice with ones like number 1 that I give you a challenge today. So let's look at these. Okay. Now, is there anyone in here that prefers the box method, or do we all like doing the FOIL? Everybody? Yeah, okay. Well, then let's just look at FOIL method today. Might throw some box in there if anybody wants to see it, but let's keep the FOIL. So for number 1, using the FOIL method, what are the first terms that I should multiply? 5x and 3x. 5x times 3x, what did that give me? Yes, 15x to the second power. 5 and 3 are 15. X and x squared. Okay, so those are our first terms. What do we multiply for the outer terms? Good, 5x times 2, what will that give us? 10x. Perfect. What are my inner terms? 2 times 3x, what will that? Yes, 6x. Perfect. 2 times 2 plus 4. All right, so we've done our multiplying. What like terms do we have, if any? 10x and 6x. Good. So those will be added to make 16x. So we'll just rewrite everything. 15x squared plus 16x plus 4. And that is our answer. Right. You guys get that one right? Okay. Any mistakes that we notice we've made that we think should be discussed? Yeah.
I just forget to
add the like terms.
Yes.
Gotcha. Yep, that is a super easy step to forget about. It's so easy to forget those little things. Anytime that we do these problems, though, and we'll start to, I bet a lot of you, now that you've done that long 20 question thing, you start to see that there's always going to be like terms to combine at the end. So the more practice you do, the more natural it will start to feel. Okay, so let's look at number 2. Now I've got something trickier. What are my first terms that I should multiply?
3x squared and 2x squared.
3x squared and 2x squared. So now we have more exponents to worry about. Let's look at our coefficients first, just the number values. 3 times 2, 6. And then our x's, yes, x squared times x squared gives us x to the 4th power. When we multiply exponents, we just add. 2 plus 2 is 4. Okay, so that's our first terms. What's our...
X squared to 4x. 12x.
Good. 3x squared times negative 4x. A positive and a negative. Go ahead and bring down that minus. 3 times 4 is 12. X squared and x to the 3rd power. Good. Good, good, good. All right, what are my next terms I multiply?
2x and 2x.
Good, 2x times 2x to the 2nd power. Yes, 4x to the 3rd power. And yeah, 2x and negative 4x. That will give us negative 8. What's our variable and exponent? X to the 2nd power. Good. Good. Okay, so we have multiplied our first, outer, inner, and last terms. What do I need to do from here? My two middle terms are like terms. They both have x to the third power. So, negative 12x to the third power.
Negative 8x to the third power.
Yes. Whenever I add these, I do get negative 8x to the third power. So, we're going to rewrite everything. 6x to the fourth power minus 8x to the third power minus 8x to the second power. Good.
You're not done, are you?
What do you think? What step did you think we could do again?
I'm thinking a negative 8 to the third power, negative 8 to the second power.
They do have the same number. They do have the same variable. Do they have the same exponent? No. So we actually can't go any further. That's as far as we go. Good deal. Good deal. I know it gets tricky whenever you see it's like, okay, which thing am I trying to match together? Because they look very similar. But no, that's as far as we can go. Okay. You guys run into any problems on number 2 with those exponents? Nice. Right. We're learning. We're doing so good. All right, let's look at number 3 then. First step.
5x to the third power, negative 2 to the third power.
Perfect. 5 times negative 2 gives us,
Negative 10 to the 6.
yes, negative 10, x3, 3 and 3 give us 6. Okay.
And 5x to the third power and x to the second power, you get 5x to the fifth power.
Yes. 5x to the third power times x to the second power, we do get 5x. 3 plus 2 is to the fifth power. All right. We've done our first terms, our outer terms. Now let's do the inner terms. 4x squared times negative 2x to the third power.
Negative 8 to the fifth power.
Good. Perfect, perfect. Negative 8x to the fifth power. And last but not least,
4x to the fourth power.
yeah, 4x squared times x squared.
4x to the fourth power.
Yes, yes, yes. The 2 and the 2 give us 4. Beautiful. All right. Now, yes. So now we've got everything all multiplied out. We do still have like terms. Positive 5x to the fifth power, negative 8x to the fifth power.
Negative 3x to the fifth power.
Yes. Negative 3x to the fifth power when we combine them. So bring it all down. Yep. Negative 10x to the sixth power minus 3x to the fifth. Bring that. Perfect. Plus 4x to the fourth. That is our answer. Beautiful. Okay. Yes. Yes. Absolutely. Let me get a fresh piece of paper maybe, because that's a lot of numbers there. Let me give everybody a second to write down the work for number 3, and then we'll come back to 2. See a few people still write. All right, so let's look at number, thanks, Brian. You're the best. I'm so blessed to be here. Brian, we're all blessed. I'm blessed. I love being here. Make my day. Okay, so let's look at number 2 again. I'll just rewrite the problem, and this time let's go through it slowly. If you got this down, quiet for a minute. You got this? Quiet for a minute. We're just going to very slowly go through this. So for number 2, we had 3x squared plus 2x times 2x squared minus 4x. Okay. And do you use the FOIL method or the box method? The FOIL method? Okay, perfect. So we're going to start with our first terms. We have 3x squared times 2x squared. And I'm going to write this out slowly. Here's our first terms. 3x squared times 2x squared. Okay. So when we're on this first step, and any time that we're multiplying terms, especially with variables and exponents, we always want to start by looking at the number, the coefficient. So I've got 3 times 2. So what is 3 times 2? 6. Good. Now I have x squared times x squared. What's that going to give me? X to the fourth power. And we're getting x to the fourth power because x squared just means x times x, and we're multiplying that times x squared again, x times x. If we counted all the x's, we would see that there's 4 total. So we're just adding the numbers. X squared times x squared is x to the 2 plus 2, which is x to the fourth. That's how we got that one. So now let's look at our outer terms. So 3x squared times negative 4x. 3x squared times negative 4x. Okay. So again, we will just look at the numbers first, the coefficients. My coefficients are positive 3 and negative 4. So what is positive 3 times negative 4? Perfect, negative 12. And now I have x squared, which is x times x, times x. So x squared times x would be what? X to the third power. We can see x squared is 2 x's. If I multiply one more x, I have 3 x's. Anytime there's not a number for an exponent, we can assume that this is like a 1 right here, an invisible 1. And same thing as we did in the first step, we're just adding 2 plus 1 to get 3. So really we did x to the 2 plus 1, and that's how we got x to the third power. Okay, so there's our first terms, our outer terms. Now let's do the inner ones. So 2x times 2x squared. 2x times 2x squared. Okay, so now I'm doing my inner. My coefficients, my numbers, are 2 and 2. So if I multiply 2 times 2, what do I get? 4. Now I have x times x squared. What will that give me? Yes, x to the third power. Perfect. Because this is like an invisible x to the 1. 1 plus 2 is 3. We're adding those numbers. 1 and 2 make 3. Perfect. And I don't think there's ever anything wrong with writing out your x's, like saying I've got 2x, so here's an x. 2x squared, that's times x. 1, 2, 3, there's 3 of them. Okay, so now we have the last terms, which are 2x and negative 4x. So 2x times negative 4x. Okay, so again, let's look at our coefficients first. I have positive 2 and I have -4. What is 2 times -4? -8. Good. And now I have x times x. What will that give me? X squared. Perfect. So I've got all 4 terms. 6x to the 4th power, -12x to the 3rd power, 4x to the 3rd power, and -8x to the 2nd power. So once we've done our multiplying, now we move on to the next step where we ask ourselves, can I combine like terms? So looking at these 4 terms that I have now, are there any terms that have the same variable and the same exponent number? Yes, my -12x to the 3rd power and my 4x to the 3rd power. So this one's negative, this one's positive. I'm going to bring these over here. -12x to the 3rd power plus 4x to the 3rd power. What do I get when I add these together? Yes, -8x to the 3rd power. So now we have our new middle term. We're not going to use these anymore because we already combined them. So at this point, we can bring the rest down and write out the whole answer. We have 6x to the 4th power. Our middle term is -8x to the 3rd power. And our last term, -8x to the 2nd power. With the exponents. So we're not understanding why we're adding them. Okay, so let me show you that. This is a good thing to go over too. Whenever we have exponents on any number, I know. So, right, exponents are just repeated multiplication. So what that means, if I have, for example, 3 to the 3rd power, no variables here. This means 3 times 3 times 3. If I had 3 to the 7th power, for example, I'm doing that 7 times. 1, 2, 3, 4, 5, 6, 7. If I multiply all of these together, so 3 to the 3rd power times 3 to the 7th power, well, let's see, let's write them all out. I have 3 to the 3rd power, which is 3 times 3 times 3. So I'm just replacing that. Times, I bring that down, 3 to the 7th power. I've got 7 of those. 1, 2, 3, 4, 5, 6, 7. Now remember, the exponent, that number tells us how many times we multiply the 3. So looking at this now, how many times do you count us multiplying 3 here? 7 here, 3 here, 10 total. So this is also 3 to the 10th power, because whenever I multiply these two together, it's adding more times that I'm multiplying that number or that variable. So I know that if I write out the 3 times 3 times 3, 3 times And then 7 times, if I count how many times I multiply it all together, it's 10. 3 plus 7 is also 10.
Yeah,
Yes.
it would have, like, for someone to understand, if you would put the plus sign, dot is, then they know the average.
Yes, but if I do this, it's a different problem. We do need to know that.
No, not like that. Where
You
the one
mean
is right there, after the third one, put a plus sign right there. No, 333 plus.
what? I don't know what you're talking about.
Like, you know where you got the big dot is? You got the first 3 down at the bottom in the threes. Go over, right there. Put a plus sign right there.
But that would be different than multiplying. I understand what you're saying. I do understand, but 3 times 3 times 3 plus 3 times is a different problem. We would get a different number. It's a good idea, though. I see what you're saying. Shayna, yes.
Correct me if I'm wrong. I think what she's meaning is like when to know, like when we're sometimes we add them, but when they're like terms, we don't add them. They just stay the same.
Okay.
Is that word? Because she was saying three. That's not what I'm understanding. Yeah. But you give it to.
Yeah. This one? Okay.
Oh, the 12 and then the 12.
Mm-hmm. When we add those together?
Yeah, just wondering why we wouldn't add that.
Okay. Okay. Thank you. Now I know what you need. Okay. Now I know. Okay, so whenever we multiply in the beginning here, that's when we add exponents because we're multiplying the terms. When we add the terms, these exponents will not change because I'm only adding how many x to the third powers I have. So this might be silly, but I have an idea. Let's make, here's what I'm going to do. Hang on. I have an idea. This might help. So I'm going to write out the answer that we got. We have 6x to the fourth power minus 12x to the third power plus 4x to the third power minus 8x to the second power. So whenever we have all of these different terms with variables and exponents, I'm going to assign each of them to like a color. So x to the fourth power is going to be orange. X to the third power, let's do yellow. And x to the second power, I'll do blue. So what I'm really saying here is I have 6 oranges, and then I have negative 12 yellows and 4 yellows. And then I have minus 8 blues. So once we've gotten to the point that we're done multiplying and we're just looking at terms, it's almost like we need to switch our mindsets over to now the exponents don't matter. Now I'm just looking at what goes together and we're only looking at those numbers. So I could see that, okay, well, my x to the third powers are my yellows. So I'm going to put those together. When I add negative 12 yellows and 4 yellows, is that going to change the color that I have or just the amount of that color? It's just going to change the amount of the color. It's just changing the amount of x to the third powers. We're not changing the exponent. We're just adding the number of it. So we would end up with negative 8 yellows. Sometimes it's really difficult, especially whenever you have the same variable. And remembering in general that when you combine like terms, the variables don't change. Because the definition of combining like terms, it's only adding and subtracting. Anytime I add or subtract exponents, it doesn't change. Like if I had 6x plus 4x, totally different problem. Will I get 10x squared or 10x? 10x. Why? I'm just adding how many x's do I have. Up here, I'm adding how many x to the third powers do I have. These do not change unless we multiply or divide. Only if we multiply or divide. Now, I wonder, and you're not going to hurt my feelings if that didn't help. Did that help at all? Does that make a little sense? Okay. Trying to figure out how to explain something like this is a little difficult. So, at any point, if anybody ever has, something that makes sense in their head that you think, you know what, if I tell everybody this, it would help them, please share, because we can help each other out quite a bit by sharing those thoughts and other things. And I also appreciate you telling me that you were having trouble with that, because I'm sure you're not the only one. Okay. So let's maybe do a little exercise here. X times X times X times X. What is this equal to? X to the fourth power, because I'm multiplying X 4 times. X plus X plus X plus X. What does that equal? 4x. Ah. What's the difference here? Yes. An exponent refers to how many times am I multiplying that thing. That thing is an x. The number, the coefficient here, tells me how many of this thing, how many x's do I have. I have 4 x's. This doesn't mean I have 4 x's, x to the fourth power. It means I have x multiplied by itself 4 times. They're different. It can be confusing. I really think the best way to get better, though, is to practice. I have some problems assigned on IXL. If you want more practice on your own time, that is always available. But yeah, and you're also always more than welcome to, speak up when you don't get something, and feel free to come in anytime that we're not in a lesson. I want to help, any way that I can. So that's our do now. That was our do now. Let's go ahead and put this to the side. I'll move all this. And let's see. And let me pause this for a minute while I grab some stuff. All right, so working more with exponents, I'm going to show you something else that you might see. So let me title my page, Algebra 1, Unit 3. Page 1. And it is day 23. So there it is. Day 23 notes. Okay. So, I want to see if you guys know what it would mean if I had something written that looked like this. What if I gave you x plus 5 in parentheses, and that was squared?
That's 6.
Before we try to find the answer, what does this even mean? What does an exponent mean? What does it do?
Times it by 2.
Not by 2.
Multiplying by. Are you multiplying by 1?
We are multiplying something. We're on the right path.
Multiplying the x by, aren't you?
Kind of. You will be doing that at some point.
X times x twice.
Almost.
What's in parentheses? You're gonna times that.
Yes. Okay, Kelsey got it. Remember that if something is squared, it means I am multiplying it by itself. The squared is outside of this in parentheses, x plus 5. X plus 5 squared means x plus 5 times x plus 5.
Times it twice.
Ah, yeah, we're multiplying it to itself. That's what that squared means. So, x plus 5 squared, can we solve that? We can use the FOIL method or the box method. It's the exact same thing we've been doing. First, x times x. So I'm going to write this down here, x squared. My outer, x times 5 plus 5x. My inner, plus 5x. Oh, I said 5. I wrote 10. Oh my gosh, my brain. Plus 5x. And now, last but not least, 5 times 5. 25. Now, after we multiply, remember when we go to the step where we combine like terms, do the exponents change? No. Now we're just looking at the numbers that are attached to the same variable. What is 5 plus 5? 10. X. So I'll bring the rest down. X squared plus 10x plus 25. That is our answer. So how about this? What if I gave you x minus 2 squared? Can you do that?
X equals -2 times x equals x minus 2.
So x minus 2 twice. We're going to multiply it to itself. X minus 2 times x minus 2. That's all we're doing. We're multiplying things by themselves. So let's do this one. My first terms, x times x is x squared. My outer terms, x times negative 2. Negative 2x. Negative 2 times x is negative 2x. And lastly, negative 2 times negative 2. Oh, positive 4. Good. Okay. So, now what?
You combine the two like terms.
Combine.
-2 plus -2 is positive. They cancel. Oh, they do that? No. It'd be negative.
Negative 4. Remember, if I have negative 2 minus 2 Or you could think of this as -2 plus -2. We're just going to get a bigger negative. -4x. And then I bring the rest down. X squared minus 4x plus 4. Nice. That's our answer. Okay.
That's what I would think if you dealt with with the 12 problems.
Yeah.
Yeah,
Those middle terms.
So that's why I was missing the middle part.
Right. So let's do a couple more of these, and I want to see if you guys notice a pattern. Okay, now let's try x plus, let's do 3 squared. X plus 3 squared. What would my problem be?
X plus 3, X plus
3. X plus 3 times x plus 3. Do this one on your own. I'm going to pause our recording, give you a couple minutes to do that. See if you can get your answer. Okay, so let's see. What do I do first?
X times X.
Which is?
X squared.
X squared. Then?
Times 3.
X times 3.
X,
3x. Yep. Now what?
Now we do 3x.
Another 3x.
Yeah, and 3 times 3, 9.
9. Okay, now the tricky part. Combine your like terms. Do we change the exponents? No. You got it. What is 3x and 3x? 6x. Bring down my plus 9. Bring down my x squared. Boom. What is it?
You take the 2 x's, you just put x squared.
Uh-huh.
And then you add the 2 3's.
Uh-huh.
And then you take them times each other.
Uh-huh. You discovered the trick. Okay, so everybody, I want to show you. Titania discovered it. I don't know if any of you else did. You might have. Anytime we have a binomial, like all of these are all binomials. If we square the binomial, there's a trick to not having to do the method. She figured it out. Here's the trick. I'll show it to you. For example, x plus 5 squared. Well, I know I'm going to always have x squared, and I'm also going to have 5 squared, because 5 times 5 is 25. That gives me my last term. X squared gives me my first term. To find your middle term, all you do is do 5 plus 5. Yep. And you get 10x. X squared plus 10x plus 25. That's our answer. We could do the same thing here. Look at this. X minus 2 squared. Well, we're going to have x squared. Negative 2 squared is what? Negative 2 times negative 2. Positive 4. And what's negative 2 plus negative 2? Negative 4. Add the x. X squared minus 4x plus x. Oh my gosh, that's what we got. What? Can you even see that yellow?
I was gonna ask.
Yeah, sorry. I just realized you can't see what I wrote. I know it. I know it. So, let's look at this again. Okay, so I'm going to square my x. I'm going to square my 3. X squared. 3 squared. What is 3 squared? It's just 3 times 3. 9. X squared stays x squared. Now, I'm going to put these together. 3x plus 3x. 6x. Look at that. Quick trick. So here, let's try one that we haven't solved yet. And let me actually write out that trick so that you're makes more sense. So, for example, x, I'm going to rewrite x plus 5 squared. So we're going to square this, square this. So we're multiplying them by themselves, basically. X squared and 5 squared, which is 5 times 5. Okay, so we did that. What you do in the middle is you're basically taking this times 2, or you're adding it to itself. 5 plus 5, but we're adding the x. 5x plus 5x, which is 10x. So that gives us our answers of x squared plus 10x plus 5 times 5 is 25. Okay, so there's kind of the rule written. Let's try this. X plus 4. What would my first term be? Oh, sorry, squared. X squared. Now this trick, you don't have to learn it. If you know how to FOIL, you know how to get the answer. This is just for fun. So x squared, and then my middle term, I'm going to add 4 plus 4 and add an x, 8x. Yes. 4 squared, 4 times 4, 16. Oh my gosh, that's our answer. That's pretty fast. That's neat. That's right. What about another one? How about x plus 10 squared? Square the first term, and we get x squared. Square the last term. Oh yeah, middle term, we'll do 10 plus 10 is 20x, and 10 times 10 is 100. What? How quick is that? So I'm going to write that again. 10 times 10, x times x. And this we just did 10x plus 10x. Okay, how about x minus 12 squared? X squared. Now we got to add negative 12 and negative 12. Yes, negative 24x. It is. 144 positive. A negative times a negative gives us a positive. Yes. So there's our answer for this. Just a neat trick. You don't have to use that trick. If it confuses you, don't worry about it. You can still FOIL and get these answers just the same. Absolutely. Okay. So pause this for just a moment. I'm going to talk to you guys. All right. So that's going to be the end of the notes. I will make an exit ticket. I will unpause again once I have it written. Okay. Boom, magic. If you're watching the video, this just appeared out of nowhere. This is the exit ticket, and that is it.